So I want to ask you guys a question. Who here has
Okay.
seen Rick and Morty?
I have.
Only up to season 3. Haven't
Everyone?
seen season 4.
Yes, I've
Okay.
seen it.
All right, then I don't have to give any background. You guys know about it. So there is some background to this problem. Of course, we have
Are you making the portal gun?
Mr. Rick Sanchez, who is always making some trouble in the universe.
Are you making bootleg portal juice?
No, we're not doing that. So he is always trying to go to some different planets and kill people there for whatever reason. But he has taken some inspiration from what's happening, and he has developed in his lab something called the Rick virus, and he has made it so that it can work on certain species in the universe. So there are 4 species which this works on. I'm going to go through them one by one, and you guys have to choose one of them because you're going to do a little math problem for each one of them. So first one are the Meeseeks. Who wants that one?
Whoa,
I'm fine.
Mr. Meeseeks, look at
Mr.
me.
Meeseeks species.
That didn't really grow fond on me.
Wait, so we each have to choose one, yeah?
You have to choose one, yes. So this is the first one.
I'll take the Meeseeks.
All right. Tom goes with the Meeseeks. Second one is the Mr. Poopy Butthole
That will be me.
species. That's Jabril. Okay.
I'm gonna wait until the end.
All right. All right.
He really speaks to me.
There are only 2 more. The other one is the Cronenbergs.
Jesus.
Cronenbergs. Weren't those also?
Three wants that one?
Yeah, I can take that.
All right. All right. And then there is the Cromulons.
I guess I'll be the Cromulons. I don't regret.
Robin.
Show me what you got.
Robin is the
Show me what you
Cromulon.
got.
Okay. Now, here's the thing. This Rick virus grows in different ways in all of these species because they are like different parts of resistant to this thing. So now let's go into this thing here. So here is the information that I'm going to give you, and after which I will define the problem. So the Meeseeks population, when someone gets the virus here, however many people have it, it doubles. The number of people who have it doubles every 4 days.
So it's exponential for the Meeseeks?
Doubles every 4 days. Yes.
Is this like that legend about how chess was invented, where the guy who invented chess invented it for a king?
Well, that also has something to do with exponential growth.
And when the king asked him what did he want, he just responded with, okay, 1 for the first, 2 for the second.
Same topic, yeah.
For the
Exponential. So now,
Christ.
so that's the information that I have for you right now for this one. Now, the second species. So I'm just going to put here Tom, so we know who's working on what. And then we have Jabril, who's doing Mr. Poopy Butthole. And this one is doubles every 2 days.
Jesus. The poopy buttholes will not survive very well.
Now the Cronenbergs are more resilient to this thing. So they go up every 7 days.
It's probably because they're already infected.
Double every 7 days. Now,
they're already disgusting creatures of ungodly proportions.
And the Cromulons, they are much, much bigger. And so it takes a lot longer for them. It's 14 days. Doubles every 14 days.
Because they're giant heads, it doesn't really take that much to take them down.
Weren't the Cromulons like gods?
Actually, wait, never mind. Didn't they get like nukes or like big?
Okay, I still got to give you some more information before you guys can work on this now. So every single population starts with the same amount. So you start with on the first day. 50 people. That's the same for everyone. Now, I want you guys to calculate how many people, or meeseeks and the different populations, will be infected after 200 days.
So it starts with 1 infected, right?
Starts with 50.
It's 50 people infected?
Yeah.
That's a lot.
So he went there and then he infected 50 at the same time with his gun.
This is going to be the first time I'm ever going to
After
Google how
200
many cromulons
days.
there are.
After
So
200 days.
200 days. Okay.
Yes. So that's all the information you're going to need. And try to do some thing that makes sense.
Whoa!
And then you have 15 minutes
Sam,
on
where
you.
are you?
So I plugged the numbers into a calculator.
Don't say anything right now. Okay? So everyone should mute themselves now. Think about this problem for themselves. Doesn't matter if you get it or not. That's not important. But think about it. And then we're going to go through it at the end of the lesson. So remember, guys, I'm going to send you guys in the chat so that you have the numbers for this. Right. So take a look at it. So I'm going to take one of the species as an example, and then the method to get to the right answer for the others are obviously going to be exactly the same with one number, which is going to be different. So let's take a look here. Which one do I want to use here? Maybe we're going to...
Wait, shouldn't everyone have a different answer?
Yes, true,
Oh,
true.
okay.
Everyone should have a different answer, but the way of calculating that answer is the same, apart from one number in there.
I have a lot
Wait,
of
it is?
ammo.
Yeah. So let's take a look.
Oh.
Which one do we want to go for then? Can everyone see my...
Sam,
No,
how many do you have?
you have to do that thing where you.
Oh my god.
Yeah, do it again. There we go. All right. So let's pick, which one do we want to do? Let's do the Cronenbergs. So Trim's species.
No,
So
Bongoms.
we got 50 to begin with. Now, of course, I'm going to think out loud while I do this. And I always like to think about things in very simple ways that I can understand. So
Wait, what the?
the problem is that we are starting with a population that gets infected. We know that. That's 50. I'm going to write that down. And then we know that it doubles every 7 days. And that's the thing that is different for you guys. And then I want to calculate how many people are going to be infected after 200 days. So the 200th day is going to be some number that's going to be quite large. That's what I'm predicting because it's doubling. So if I get something that's just like 1,000 or something like that, it's probably something is off. So in my mind, I'm making a prediction that is a range probably, which is a very large number. I'm thinking like millions, maybe even billions. So, or maybe it would, yeah. So definitely somewhere there, I'm thinking. So it's important to guess because guessing is very good. And then you can kind of figure out a way to get to the exactly right answer. So let's think about it from day to day first. So if we're starting off from 50, let me just make an arrow here. And I'm going to say 50. And then I'm going to say X. Now, what is X? Well, X is some number because I know that this thing is growing day to day. Now, it's not doubling day to day. It's growing day to day. Now, I know that if this thing is growing constantly, like with a constant, there is some percentage by which it is growing from day to day. I don't know that. Maybe I want to find that out. So I'm just going to write that as X right now. Now, that's day one. Or sorry, so this is day one. So that's day two. So from this day to this day, Actually, you know what? Let's make it so that we have day 0 and day 1 because the calculations are just going to be a little easier, like this. Now, what is this thing going to be from day 1 to day 2? How can I write this? 50 something. Any suggestions? Yes, Robin?
Oh, hold on. This is day 2, so it's supposed to be like 50x. If we're using the Cronenberg switch, aren't they like 7?
Yeah.
Then it probably should be like, if it doubles every 7 days, then it should be.
Yeah. So
I can't do the math in my head because
yeah, exactly. See, that's a very good point. You can't do the math in your head, and that's what we're trying to get to. So
calculator time.
right now, it's not important that we get exactly the right answer. Right now, what's important is that we go consistently up day by day. So if I'm thinking that this thing is growing a little bit every day, maybe some percentage, maybe it's 10%, 20%, 30%, somewhere there, then I know that if that percentage is the same day to day, then I can just do x times x here because it's another day. That can also be written as x squared. Day 3, what is the expression here going to be?
X3?
Yep, absolutely, x to the power of 3. So you get the idea, right? This is the pattern. So let's fast forward to day 200. What is this expression going to be?
X 200.
Yep. Now, before I go up to 200, I know that this thing is doubling every 7 days. So let me calculate that. Let me calculate the double. So we go up here. Now let's go up to 50 x to the 7th power. This is day 7 now. This should double by now. What is the double of 50?
100.
100. Now we have some more information. Remember, the doubling is not something that gives you the answer right away, but it gives you a method to get the answer. So right now I'm thinking here that on the 50th, on the 7th day, I have this expression right here. Equals 100. This is an equation. Now, it might be an equation that you think is hard to solve, but it's actually not that hard to solve. Because what can we do to reduce this thing? What can we do on both sides to get
Instead of
x?
101.
Divided by 50, both sides.
Exactly. Divided by 50, that's going to give us x to the power of 7 equals 2,
2.
right? 100 divided by 50, that's 2. There's 2 50s in 100. Now, how do you do this? Well, this is where a calculator can come in hand.
Oh,
So
God.
I'm gonna go to Google and just do this calculation. Let's see. Square root.
2
I can take that
to the
last back
square
here.
to the square root, the 7th root.
No, see, the thing is,
Wait, how do we do nth root? Nth root, Google. Square. Square root. Does anyone here have a calculator where they can put in the 7th root?
No.
Maybe.
I'm gonna look it up on Google.
Yes, I have a calculator
Yeah?
where I can put in the 7th root.
Can you do that? Can you? So this is gonna be this. So the answer is gonna be x. It's like this.
Oh no, I don't think I have.
Yeah.
that.
So the what we can do here.
Oh wait, that's square root, right?
Yeah, we can use
Oh yeah,
Wolfram
yeah,
alpha.
yeah. I can do that. I can do
Yeah?
that.
Okay. I can use Wolfram alpha to do this too. X to the power of 7, which is equal to 2. Now that's going to give me a number which is
Very small.
Wait, that's it. Calculate. Did you get that number, Tom?
Did I get one number?
Yeah, the number for this.
I solved it a completely different way.
Okay, all right.
Same here.
I see that.
So, why am I not getting the appropriate form here? Oh, there it is. Wait, approximate form. That's what I want. Yes, I got it. I got it. This is the number. So this is going to be approximately equal to 1.1041. Now, if something is more than 1, then is this thing still increasing or decreasing?
Still increasing.
Yes.
Please.
Now, if it's less than 1, it means that it's increasing. It's already reached its peak. So I know definitely that it's increasing. Now, the way to do this is that you just take the numbers after the comma, and that's how you get the percentage. So this is going to be 10%. So I'm just calculating some extra information here. You don't necessarily need to do this, but this thing is growing 10% day to day. That's what I got from it doubling every 7 days. That's the information that you can deduce from that. Now, how do we get this thing after 200 days? So that is going to be, let's see here. So it's 50 times 141, which is the x. Okay, it has to be more than 1 because we want it to increase. Now that to the power of 200. Any guesses for what that number is going to be? 50 times 1.1041 to the power of 200. That is 20 billion.
You got the wrong answer.
I got the wrong answer?
No, me.
Oh, what did you get, Tom?
I got 5.
What did you say? 5 what?
5,000.
5,000, really? Okay.
Yep.
Yeah. So,
Really well contained.
all right. So 200 days, you let something go for 200 days, starting at 50, it's at 20 billion. So from this, I'm sorry I'm going a little bit over time. Is it okay if you stay for another 5 minutes?
Oh yeah.
Yeah?
Yeah.
Okay. So are there any questions here? Anything that doesn't make sense?
Not really.
I wanna ask you guys how you thought about this problem. Yeah,
I
Robin.
did it by first taking the amount of days, which was 200, dividing it by the amount of days that that the infected would be doubled on. Hold on.
Well, so
Thank you. And then I got the answer. I divided 200 by 14, which incidentally was 14 as the answer. I rounded it out from 4, and I can read out what the answer would have been if I didn't round it out, which would have been I accidentally removed it. Well, that's okay. And then what I did is I took 50 times 2, because if there were 50 infected and it doubled every day, it would be 50 times 2 to the power of 14, which is 50 times 16,384, which is 819,200 infected by day 200.
800 and what?
I used my math book, which is now on the ground,
Okay.
to throw it back to find out what because I've done what 2 to the power of 14 was in school, which is 16,384. I times 50 by that, times 50. And the answer was 819,200 infected by day 200.
Okay, so we can find out if that's the right answer because I just came up with a formula for this. So the x for you would be x still, of course. That's what we want to find out. This up here is 14. This is the number of days that it's doubling on. So here we can do again 2. That's going to be the same. So we then would have this 14th root, which let me find that out here. So that's going to be 14. So this is going to be approximate form. So that's going to give us a growth rate of 1.0508, also known as 5.1%. Now, if we take this number now and do 50 times x, which is this, and then take this to the 200th power. Before I calculate this answer, remember the last one with the Cronenberg's, Trim's one, was growing at 7 days. This one is growing at doubling every 14 days. Make a prediction. That was 20 billion. Which number is this going to be? Is doubling
10 billion.
every 14 days instead of 7?
10 billion.
10 billion? Okay, good guess. Half of it. Any others? No?
Yeah, 10 billion.
10 billion? Okay.
About.
That makes sense, right? Because it's 14 instead of 7.
Wait, are we talking?
But actually coming.
Wait, was the Cronenberg's 14 or
Yeah.
7?
So Cronenberg's, the Trim one was the one that we
I
did
understand.
before. That was 20 billion, doubling every 7 days for 200 days. This one, Chromulons, are doubling every 14 days.
Oh, so it's 40 billion.
What?
40 billion?
Yes.
Okay, you doubled that. And someone said 10 billion. Jabril, you said 10 billion.
Yeah.
Yeah, okay. Do you know what the real answer is? You're way off. Way off.
Oh wait, because it's
You got this, Em.
Yeah, no,
I
it's
know
wait,
you're not
yeah.
Trim, you gave me an expression there. What do you think? You're muted.
Because it's doubling every time. It goes less and less and less and less than the 7 days I got. So it would be, I don't know.
Is it going to be more or less than 20 billion?
Less.
Yeah, way less.
Yeah.
You think
less.
logically.
Oh, wait. Now I realized why I chose 10 billion.
Exactly. So a person would think, well, it's 14 days instead of 7 days. So logically, 14 is 2 times more than 7. So that means it's not going to grow as fast, probably half as much, 10 billion. That's what a person would think. But remember, this is not linear growth. This is exponential growth. The actual answer is 1 million. 1 million people after 200 days. Only 1 million. Not 20 billion, 1 million. That's the difference. Okay, so I'm not going to do the rest because we're way over time, but this is a perfect example of how you can deduce a formula. Now you can do any calculations that you want, whatever you want to simulate this with. So the first part is the number that you start with. You always have that, the starting infected population. The second number is going to be the growth rate. Now remember, your population is growing. It always has to be a number larger than 1. Make sure that it is. If it's less than that, it's going to start, it's not going to, it's going to go down. So when you have 1 point whatever it is, let's say that it's, for Jabril and Tom, it's even higher because they're doubling every 4 days and 2 days. Calculate how much that is going to be.
Yeah,
so whatever that number is,
the hardest.
Yeah, it hit you the hardest by a lot too. So let's say it's something like this. Then you take that growth rate and you take it to the power of the number of days, or you can also say minutes or seconds if you're doing second-wise or something like that. And then that's how you get the answer. Does that make sense to everyone? Do you kind of have an understanding?
Yeah.
Yes. Yeah.
Okay, good stuff. I've recorded this session, so if you want to go through it again, I will post this on Discord. And so you can go through it by yourself if you want to kind of dig deeper. Yeah. So thank you guys for today, and have a great week. And I'll
Thanks
see
for
you
today.
next time.
You too.
Goodbye.
Thanks. Bye.
Bye.